to dominate, really, what American and Asian.
So this is what we've got.
But I think, and that's in the rounding, obviously, of the edges. The idea that you can get more space into a smaller package, a more usable interior space than.
So at the moment, I'm only using the RF output from a VCR, and we lost signal lock. That's why is that? Why did we lose? Is that the horizontal lock that just died?
Japanese cars have ceased to be inexpensive. Well, the Asians
Come on.
obviously become much more expensive.
Anyway, this thing is a little bit finicky right now. I can get audio through, and I managed to do that mostly by twiddling the controls, but also by cranking on the two IF cans in the actual sound IF circuit. Now, I don't have a proper marker generator and all that jazz in order to do a proper alignment on this set. There's really not much that I can do with my given equipment outside of peaking the two sound IFs with a voltmeter. However, I did go through and find some problems in the set, besides the standard bad capacitors that I already dealt with. So that's kind of obnoxious, not gonna lie. Either way, the audio was my first clue. I got the channel set correctly and everything, but you notice we have really bad horizontal and vertical lock. My first suspect was that there might be some problems in the sync circuits. Last TV I worked on had basically all of the resistors and caps in the horizontal and vertical were just completely dead. Even the ones that seemed to be okay, especially the silver marcas, wound up replacing all of those, made it incredibly stable. This, however, is the result of a completely different problem. I already checked the sync circuits with my scope. The pulses and everything are exactly like the schematic shows. They should be. But while I was watching a video from Shengo66 on a virtually identical set, GE, I guess, also made some for Hotpoint, which I think was an Edison appliance brand, which has the same tube layout, same chassis, just a slightly different exterior. What I didn't realize is you can actually inject a composite video signal directly into the video output amplifier tube, which does make sense. So I'm going to do that real quick. We're going to unplug the RF from this thing because it is driving me crazy. Okay. RF's uncoupled. Now, if we use the handy, convenient test point at the back of the set, that is actually designed for setting the waveform. Now, we actually have a watchable picture that stays in sync. I haven't dealt with the vertical linearity, height control, and all that jazz just yet, but I will eventually. But on the whole, it all seems to work pretty good if you just, well, bypass everything. Now this is color video, so it's not as good as it could be, and from what I've read, these little double IF stage video stages don't really produce that great of a picture. It's a portable set, so the clarity and the quality of the incoming signal isn't going to be great. But it does work, and that's all I really looked for. However, we're still not using the actual RF section. We're just bypassing everything and going straight to the video output, which I can show you right here. So bear with me here. This is a PDF of the schematic. This is test point A, which is at the back of the chassis. And the video output tube here amplifies the video signal detected in this box. We've got a 1N64 video detector diode, which comes off the last video IF stage. There's only two. You've got a pair of 3 CB60s that handle that. Then once it comes over, passes through this cap to the grid of the 6AU8, and then that comes out and heads over to the control grid of the CRT. Now this set, I was reading my Fundamentals of Television Servicing book. I realized this set actually uses a later style of audio pickoff. So in early sets, the video and audio IFs are separated at the very very beginning, so all the way over at the beginning, directly after the mixer, you'd then have both rows, one for the sound, which is up here, and then one for the video. On this set, what they actually did, a later design, is they made the IFs in the video stage extremely broad, so that the entire wave could pass through sound and video. The video gets decoded and output to the picture tube, but the audio is still with it up until this point here, and this is actually a wave trap to prevent the audio from showing up as bars on the side of the screen or something. And it's picked off, I believe, the plate of the 6AU8 and brought back over here, and then that goes through. So I had sound, so obviously something was working, but I wasn't getting very good video, and I wasn't getting very good sync. So I started going through in all these little green circles. I started checking every single resistor I could find. I only found one that was out of tolerance, that actually doubled in value. Checked all the controls, cleaned all the controls, checked all these waveforms, and I got, they're kind of crappily drawn on here, but I did get these proper sync waveforms and everything. So my thought was, well, what on earth else could it be? So I kind of exhausted all my ideas. I know that if I input a composite signal into a 3CB or the 3CB6, or sorry, 6AU8 grid, we get a good video output, good lock, good sync, so we know that the sync circuits are not at fault, which means it's probably somewhere in the video IF section. Now I did goof with almost all of those settings, so I thought maybe I threw it off really horribly wrong, and I really need to get myself a marker generator to set all this up. And then I kept watching Shango's video, and his set actually had a problem, just like mine did. Crappy video output, wouldn't sync properly, and he compared it to a good functioning set, and what he discovered is actually over here. This can contains a few video peaking coils, as well as the 1N64 video detector diode. That's not so important. I actually checked my diode out, and we can actually just pull that off there. So there's our diode on the right side. I'm going to avoid touching it because this is still playing. But tucked up underneath there, and it's a little hard to see, there is what looks like to be a 2-watt power resistor. That is actually a peaking coil, which I did not know. So I'm going to unplug the composite here. And here we lose sync. And I'm going to try something different real quick. So here we are back to our crappy video. You can see we kind of have horizontal lock. Vertical is still rolling all over the bloody place. But now, I'm going to grab a test lead and go between here and here. And wow, what a difference that makes, except for the vertical rolling not being really nice. There's some jittering, some black bars, but overall, it does seem to work. But we can hear some crackling in the audio. And some general jitteriness in the picture. But what I did was to bypass a coil that goes from the video detector stage to the actual video amplifier tube. And this is something I would not even have considered was wrong. And, well, it was just because of Shango 66's video that I even considered it. In his, both the video detector diode was dead, and he found that he surmised that since the problem lay between the video tube, which got a good clean output from a composite signal, and the IF stages, which his IF stages actually seemed to work okay. Mine, I guess, do as well. So it had to be somewhere between those 2 points. Well, yes, it actually was. In my case, or in his case, the peaking coil was completely dead. That is a very bright spot there. Must not have been grounded very well in the picture tube. So for reference, here's our video section again. So here's the can that I opened up. We have our video detector diode, mine's good. And here is L21, which is listed as having a resistance of 4 ohms. And I went ahead and I measured it, and what do you know, mine comes out at almost 10,000, which is definitely going to be a problem for a fairly, because I mean, sure, the plate here is 125 volts, but after passing through a cap and all this jazz, and even then, this 130 volt source has to go through a 22 meg resistor plus some others, so the voltage here is going to be pretty darn small. I mean, the bias of the grid of this tube is only negative 2.7 volts, so our input's going to be fairly small in amplitude. But even then, having an extremely high resistance is going to cause problems one way or the other. In Shango's set, this thing was completely dead. In mine, it was just good enough to allow a signal through to attempt some functionality, but not good enough to allow the video signal through and to get a good horizontal and vertical lock. My hope is that by replacing this with a new one, I'll not only get good pass for the video signal, but the glitching that I see by using a direct shunt across it will be eliminated. Because I'm sure it does something important, I just don't have that good knowledge of all of these analog systems, especially when it comes to frequency modulated stuff. Now what's interesting is if you go down to, and I think Shango noted this as well, if we actually go down to the parts list here, L21's a series peaking coil, okay, 4 ohm resistance, great. It's listed as being 5.6 microhenries. I thought, okay, so I looked those up. But out of curiosity, a lot of manufacturers, they also put in parts suppliers equivalents to that part. So, like, for example, you have the GE RTL whatever, or the Meissner 19-1004. But the Miller are the ones that I tend to see the most on eBay or at swap meets. Now this one says it corresponds to a Miller part number 4610. So I looked that up, and what do you know? The 4610 is still available. Well, not being made anymore, but the specs and everything are out there. However, the 4610 is not a 5.6 microhenry part. It is a 6.2 microhenry part, and the data that I could find on it seems to indicate that it was originally made with a little bit of an internal resistance, like it was a dual component of some kind. Now, I don't mean the resistance inherent to the actual inductor itself being a coil of wire, but like it had some additional parts in there to give it a DC value. Very interesting. So I found a guy on eBay that had a few of them, and I ordered them up. So the hope is I get those in maybe next week, pop one in, and see if this thing works. In the meantime, I bought some paint, and I'm going to start stripping down the cabinet of this thing and getting it clean. So here's the case as it sits. It doesn't look too bad, but it's, well, it's got some rough spots. Dents and such in the surface, a few areas up here especially where there's nothing gone, and a whole bunch of random nastiness on it. And a fairly good sized dent in the bottom, not to mention. A lot of missing paint. Chrome's in pretty good shape though. But I'm gonna have to deal with this thing. Screen protector is also a tad scratched up. Now I'm not quite sure how to get it out of there, as these metal clips that are retaining it are a real bugger to try and get to release. They refer to it as safety glass, but it is definitely not any kind of glass. But it's riveted in at this end, and these have got to be able to release somehow, either by pulling them back or I don't know. Because I want to be able to bead blast this. I also need to get that GE logo off there if I can. I don't want to damage it. And oh, it's glued in place. Great. But I bought the wrong shade of blue, so I won't be able to do the paint work on it yet. I'm going to have to take this with me to the hardware store. Well, there's no more of the dents. This thing got kicked a few times. But that's it for this one. Thanks for watching, and I hopefully we'll have this thing nice and cleaned up and properly working too. That's going to be fun.